Hello. Good evening, good afternoon. I don't know when the evening starts, probably just after this talk, I suppose. Thanks everyone for coming. My name's Joe, and this talk is called The Craft of Handmade AI, which I admit is a little bit of a sort of clickbaity title, but hopefully it will kind of make sense as we get into the talk. It's kind of about AI and how some of the tools that AI has kind of produced have come together to contribute to a project that I'm working on, a new game, which I'm going to show you. So if, like me, you're on Twitter or LinkedIn, you've probably seen a lot of people posting the new AI kind of tools that are generating 3D models and textures and code, even whole games these things can spit out, sort of simple ones. But it's kind of scary, and I think a lot of people are thinking, is this the future? Is this going to affect my job? Certainly, it's a worry that I've heard, and sometimes I feel, what does it mean for us? I'm going to take it back in time a bit to the 1930s. Another young artist, creative, was worried about new technology and about what it would mean for them. This is Pablo Picasso. When he was starting his career as a painter, photography was the new technology that everyone was worried about. It was changing the world. And this is what he had to say about it. I've discovered photography, now I can kill myself. I have nothing else to learn. What's the point in painting a portrait if a camera can take it more quickly and more accurately? So is this it? End of the talk. Just lie down and accept the machines are in charge. I don't think so. I'm not ready for that. So Picasso also said this about photography. When you see what you express through photography, you realize all the things that can no longer be the objectives of painting. Why should an artist persist in treating subjects that can be so clearly established with the lens of a camera? And I think we also have the power to change the subject of our work. This is an example. The painting is called The Weeping Woman by Picasso, and it's something you couldn't photograph, right? It's a style of art which photography can't touch. Game development has often been focused on realism and technical processes. Now, how can we optimize the frame rate? How can we squeeze more detail into a collection of polygons? How do we simulate the light coming through the petals of a flower? How does light cast shadows across a wall? How does cloth crinkle and move over a character's arm? A lot of these technical concerns were the same things the realist painters were interested in, how to make things look like they should look. But perhaps AI can help us in some of these ways. Perhaps game programming won't all be about cache-efficient memory layouts, and 3D art won't be all about UV unwrapping, and 2D art won't be about memorizing Photoshop keyboard shortcuts, But I'm not saying throw AI out either. Picasso didn't just avoid technology, he used it. He cut up newsprint and photography and created collage, a new art form, which incorporated the product of these machines to make new art. But I just don't want to just talk about Picasso. I want to talk about what AI is enabling and how I've been embracing AI to make better games. So a bit about me. My name's Joe Bain. I've been a programmer for 15 years and a Unity game developer for about 8 years. I'm a freelancer. I've been a freelancer for most of my game development kind of career. I'm now a company founder too. I started Hairy Heart Games about 4 years ago. And we do a mixture of original IP, work for hire, and lately just surviving. But this was a title we put out at the end of last year, Rally Alley Alley, so it's a racing game.
Did you come through the forest? Yes. It's a wee bit out of control at the moment. It gets darker. And all the terrible things that have happened to us are held in its branches. There's some magics aren't made for meddling. The thing, their magic isn't meant for humans. It's a strong magic to keep at night like this.
So that's Cracker Nuts. I forgot the video autoplayed, sorry for the no introduction to it. And it's a narrative adventure game, a cinematic narrative adventure based on a Scottish fairy tale of the same name. We've been developing it for about 9 months, and we're currently looking for a publisher for it. But I'm going to talk about how we use different AI-powered tools to make the game. So first, I want to talk about what is AI. The rise of ChatGPT, DALL-E, and many of the other sort of new tools in the last few years has made AI kind of synonymous with deep neural networks. I studied AI at university in the 2000s, before neural networks were really a useful tool. But there's many tools and techniques which I think fall under the banner of AI, and especially if a company has AI in their name, I think you can take that. There's quite a broad sort of spectrum of things they might be talking about. So I don't want to be too strict with my labels. Instead, I'm trying to talk about new technology, new advances which we've used and which help make games better. So the first thing I want to talk about is photogrammetry. This is a handmade puppet made from wood, wire, foam, felt, hand stitched and hand painted. Her name is Kate, and there's only one of her. And in fact, she is currently at the Bits showcase at the Barclays Bank, if you're heading there after. She was made by a model maker named Gretchen Maynard-Hahn, who's based in Edinburgh. So far, neither OpenAI, Meta, or Google have released any AIs that make puppets. In our game, we scan Kate and the rest of our puppets, and so it's using photogrammetry. We use Polycam to do our scanning. It's an iPhone and Android app. We put the puppet on a small turntable, and as it spins around, we take hundreds of photographs. These are fed into the pipeline. You may be familiar with photogrammetry already. It's been used in video games for at least a decade on lots of titles, from sort of AAA down to smaller ones. And it's a pipeline that's continuing to improve and get more and more useful. Modern camera technology as well has made it more accessible. We use iPhones to do this, where in the past I think you would have needed a more specialist setup with DSLRs, etc. It's not perfect though. You can see in this model the kind of hair is a bit blocky. There's the sort of beard, Kate's beard is a bit attached to her neck there, and there's a few other kind of details which are not quite how the model looks in real life. So I want to also talk about Gaussian splats, which may be something you haven't heard of. So this is a 3D render of Kate made from the same set of photographs, but stored and rendered as a kind of point cloud. The hair on her head and neck is a lot better represented, I think. You can see the grains a lot better, and the separation between the beard and the neck is there. Even the sort of support part at the back, you can see the sort of shininess of that. And this is sort of shows you how that model is composed of lots of tiny particles that kind of come together to represent all the fibers and details of the model. So, and what that means is usually we have a PLY file, which might be familiar to you, sort of common format for point cloud data. Each point has a position, a three-dimensional scale, a transparency, and a color. They use spherical harmonics, which means the color can vary depending on the viewing angle. And that helps with shiny materials and reflective surfaces. They're sorted by depth and rendered as 2D ellipsoids on the screen. And this video is showing the kind of training process for that. So input images are fed in to the into the algorithm, and it kind of moves, merges, resizes the small particles to get it closer to the image that it wants. And obviously with hundreds of images from different angles, you know, they kind of converge to a representation of the object. So yeah, tools for splats. If you want to try them out, you can do that right away. It's pretty accessible. So we use Polycam, as I mentioned. They have a traditional photogrammetry pipeline, but they offer export now to Gaussian splats. Luma AI as well have a good pipeline for this. They have an app. I have an app as well. You can edit them in Blender with a plugin. Because they use the PLY format, they're actually quite well supported in a lot of 3D tools with just small kind of adjustments. And on the rendering side, there are plugins for Unity and Unreal, and a few other engines as well. So they're quite widely supported already, even though they're quite new. And this is an example of a Gaussian splat in Unity. So this tree is one of the models that we made, and you can see the kind of cotton wool, fluffy leaves are really well represented, and especially compared to the ones in the background, which come through the traditional photogrammetry pipeline. These are, you know, polygon models, and they really don't look sort of similar to the actual models. But you can move and scale them, and they work well with the, you know, the triangle pipeline as well. The depth buffer and the transparency works as you'd expect. There are some limitations though. This QR code has got lots of links to lots of papers and other resources to do with Gaussian splats if you're interested. But yeah, limitations. Lighting at the moment, you can't really light them very sort of well or very easily. So for certain scenes and things, that can be a problem. You can, on the flip side, compared to traditional photogrammetry, if you shoot lighting in the scene, if you're capturing a scene with specific lighting, that's much better represented. So you may not need to relight your scene. You may just want to fit your lighting in with the lighting that you captured. Animation is a problem. They're good for backgrounds for static objects, but there's not an easy way to animate these things at the moment. But this is a really active area of research, and there's lots of kind of papers coming out or have come out in the last kind of year, looking into different ways of animating them. Equally performance. They do run already interactive frameouts on phones and everything. You can try that in like the Polycam app or other apps. But if you want to do a whole game with them, I think you might struggle. I found that you could maybe get half a dozen in a scene before it was really sort of starting to slow down. And obviously that depends on your platform. But again, this is an active area of research. I think we'll see big improvements in the next few years of how quickly these things can be rendered and the sort of file sizes too. Cool. So yeah, the next kind of technology they wanted to talk about was NeRFs, which is a great name, I think. It stands for Neural Radiance Fields. This is a video from NVIDIA showing kind of how they work, and it's a similar kind of pipeline. They're sort of related technologies, but you feed in a few photographs, and in this case, and it produces a 3D rendering for you. Again, it represents the hair well, the sort of glossiness of the camera. It's very kind of true to life. The way it works is, in this case, you have a neural network in the process directly. That network is trained on the images, similar images that you might feed into a photogrammetry system. And then querying the image on a sort of pixel by pixel basis. It's kind of similar to ray tracing. You're doing one thing at a time, and it will return to you color and depth information, transparency information that you can use to build up your image. So because of that, it's quite slow, and it is kind of similar to ray tracing. You might be waiting a few minutes for an image, but I'll talk more about that. So again, this is something you can try out. Luma, their app supports Gaussian splats, but also NeRFs. Verlinga is another platform which is targeted towards games and also virtual production. And they have a web app that you can upload your photos to. There is a couple of other platforms. Nerf Studio and NVIDIA Instant Nerf are two desktop applications. So you're running them yourself rather than in the cloud. And Nerf Studio is a bit of a research platform. So you see a lot of the newer techniques kind of appearing as plugins for that. But if you're really interested and want to get into the details of it, that's a great one to check out. And there's also engine plugins. Unreal and Unity both support these. Unreal is a bit better supported, I think, because they tend this particular thing. Nerfs tend to be useful more for virtual production, in the sense that if you can guarantee that you have a very beefy computer running the system, then your frame rate's going to be okay. But yeah, Luma and Verlinga both have supported plugins for Unreal. Yeah, again, there's problems and benefits with these. Animations, as with Gaussian splats, there's not really an easy way to animate these at the moment. So they're better for kind of backdrops or static objects. Performance, again, is a problem. There's a lot of work towards that, though. I think it's moving quickly, so it might not be a problem, in the future. They are hard to edit, I think, because Gaussian splats have this PLY format. They're kind of a point cloud, but with a few tweaks. They fit into the existing pipelines quite, better. But Nerfs are kind of a black box. You have this neural net, and you can't really get in there and adjust it and edit it very easily. On the other hand, I think realism is as you maybe saw there, and if you look more into it, they're very good at representing a realistic scene, and they're quite easy to capture. I think they're quite forgiving to an extent with what you're feeding into them. With a lot of photogrammetry, it does take a certain setup. You have to be careful with your lighting. You can't have a shaky camera, all of this. Nerfs, because I think of the neural network, that can kind of fill in the gaps a bit and smooth over some of your kind of shaky camera work. And you can also integrate them with other kind of AI tools, which is an interesting thing. I think maybe something we'll start to see more of. So children of Nerf. There's lots of, as I said, it's a very active sort of research area. So there's lots of variations on the original Nerf paper, which are focusing on different things. I wanted to mention a few just in case you're interested, and you can follow this QR code to see a longer list of other sort of papers and tools. Fast Nerf is a technique of just basically speeding them up, caching the radiance field, and they claim up to 200 FPS. A lot of these sort of FPS numbers that you see around these things they'll be thinking of kind of very high-end sort of graphics cards, but nevertheless, it's kind of real time. SNERG, which is a great acronym, I think. I don't know. Sparse neural radiance grids. They use a voxel grid again to sort of speed up the rendering. Kilo Nerf, thousands of tiny multi-layer perceptrons. Again, a sort of another approach for speeding things up. There's this Octree approach, which more interesting research. And then my favorite one, Smurf, streamable memory efficient radiant fields. I think they come up with the acronym first and then work backwards. But that's an approach for doing very large scenes, so like whole city blocks or whatever, and chunking the Nerf into these different things. To enable you to do that. There's also an interesting link between Nerfs and generative 3D. So this is an example of Google's Cat 3D generative 3D pipeline. It's not an area I'm massively into, generative 3D, but it's interesting to see how they interact. And the way they do this is they synthesize 2D images, and then they feed those into their Nerf sort of system. That then generates a 3D representation by kind of filling in the gaps and imagining the back of the model or whatever. And then you can then extract the 3D models from them, either as Gaussian splats or into polygon models through basically virtual photogrammetry on the sort of 3D representation that you've got. Cool. So yeah, that's a lot of stuff all about object capture and scene capture, I suppose. The other part to our process on Crackernuts has been motion capture, performance capture. And we've been using a lot of markerless motion capture, which is a really interesting field as well. So we mostly use a system called Move AI, which is another iPhone-based tool. So we have 4 iPhones on tripods, and you can see here junior developer Marlon doing the sort of calibration routines. And with this, the actors don't have to wear any suits or special markers. They're free to kind of move around as much as they want. We found it really easy to set up and get going with. It's, you know, something that is continuing to improve, so there were some bugs in it, but I definitely encourage you to give it a try. And yeah, it does have some drawbacks. There's no support for props at the moment, which was a bit of a problem for us. You also can't exclude people from the capture. So you may see on the side here our sound guy, David, sort of wearing a big sheet to avoid being picked up as a human. But yeah, it can deal with really fast movements and stuff. So it was really great for the actors, I think, especially at our kind of range, our sort of budget. You know, the alternative would be probably inertial suits. And I think that, you know, not having to put on a big sort of outfit is quite nice. So looking at the output of that, so this is an example from one of our test captures. So you get very little foot sliding, we found, and no drift really, compared to like inertial suits, which over time will lose their kind of ground truth. So that was great, especially with 2 actors who are interacting. Accuracy is definitely not perfect, and it's not as good as what you'll get out of a, you know, fully equipped motion capture stage. But for us, especially with the kind of puppet aesthetic, it was fine. More cameras can help with that. We use 4, you can use 6 or 8, and especially if you want more actors, you can add more cameras to the system. And their backend's always kind of improving. So even 6 months ago when we did this, they've released updates that should improve the animations. You know, I think some cleanup is probably going to be useful, but there's lots of tools that you can use for motion capture cleanup. So, you know, you've got a lot of assets there to, you know, a lot of tools you can use there. Cool. So there's lots of alternatives. There's some alternatives to Move AI. It's not quite such a open research like area as NERFs or Gaussian splats, where that's a very academically driven sort of area. And so there's quite a lot of open implementations and papers and stuff to read. I think with this stuff, it's a bit more sort of proprietary. Move AI definitely seemed to be the forerunner in the field, but Rococo, who make the inertial suits, they have a camera system too, which uses 2 cameras, so you can check that out. Vision Pose is a Japanese company. They do sort of pose estimation, a bit more targeted to kind of medical and industrial kind of uses, but they do have a UNC plugin. And a couple of others, MediaPipe from Google and Ultralytics YOLO, which is another good name, well-named sort of product. Those are a bit more sort of developer-centered, you know, running off a single camera. But if you're interested to get into that level of the API sort of stuff, then those can be good. Cool. So I wanted to finish the talk by talking about kind of what the human side of this, what the AI stuff has enabled for us, because that's kind of what it's all been about for me. The technology is really interesting, but I'm also really, you know, the reason we use this is not just as, you know, because it's kind of technically interesting, but because of what it enables. And one of the big things was how we were able to collaborate with people from outside the games industry. So we worked with model makers, obviously. We had 3 model makers on the project working for about 4 weeks. And the process follows a fairly similar sort of process to what you'd expect from a digital 3D model making. You know, they start with concept art, and then they're building out the models, you know, with sort of wood and things rather than, you know, polygons. But then painting, sort of texturing, I suppose, making clothes for them. Then obviously the scanning, because we used an app, the model makers were able to scan it themselves, which was great. There's a bit of cleanup probably involved in that, but that's what you'd expect. And then obviously rigging, we had a 3D artist to do that. Although there are some AI tools which promise to do rigging as well. I'm not too familiar with them. And in terms of cost and time, it's pretty, you know, comparable really. I was really impressed with how quickly they were able to work. So we had, over that 4 weeks with 3 model makers, we had 3.5 environments done and 5 characters. So there was a lot of, you know, really productive sort of way of working, I think. And yeah, working with actors can be interesting too, especially if you're on the kind of indie sort of side of things, or even the kind of mid budget. I think traditional motion capture has meant that it's quite hard often to work with full performance capture. You know, maybe you'd have voice actors or whatever, but you know, being able to work with kind of full performance capture is great, but also has a lot of challenges. So rehearsal was something we underestimated, and I think we would do more of next time, allowing the actors to get into it, especially if they haven't worked with motion capture before. You know, it can really take a while to get the hang of it, working without, you know, in that environment. Script writing too. Our initial script was had a lot of branches in it. It was really good for gameplay, but it was really hard to act, to perform. You know, it was kind of like doing a choose your own adventure book kind of live on stage. So the actors were having to have the scripts, and then every few minutes they would turn to the other page or whatever. So we had to revise that and make it a bit more streamlined so they could act the whole thing through. And that's so that they can kind of, you know, hit their marks basically, so that when you have two branches that come back together, they're in the actors are standing at the same place. So that, or if they, you know, two branches come apart, then, you know, you can't edit those together so easily as you can with just audio. And also the importance of anchors. So what I mean by that is some of the actors had problems kind of getting into their lines because they didn't have costumes, they didn't have props, they didn't have a set to give them those cues, you know, of where they were and who they were playing and stuff. And so it did mean more rehearsal time for them to be able to kind of internalize all of that. And also, yeah, matching the person to the 3D model. So, you know, if the character is shorter or wider or whatever, the actor needs to maybe accommodate that so they're not clipping through themselves. Or you saw we have this kind of witch character with a big headdress, and her head movements need to probably accommodate the fact that she's wearing this big thing. So we'd love to get, I think, some real-time preview stuff so they could work with that a bit better next time. And yeah, the last part of that is, I think, creative diversity, and that was really uplifting for me, being able to see all the different perspectives. So working with people from theatre, working with the model makers, and obviously the game development staff, they all bring their different kind of views to the project, different ways of looking at problems and characters and stories and stuff. And it, you know, was really, really fun to work with them all. And I think it hopefully produced really sort of standout results in the sense that they're different from, it's a different type of game to a lot of other games, you know, because of the variety of input. You know, it also meant we had quite a sort of gender inclusive team. You know, games is still a male-dominated industry, but that's not the case with theatre. You know, so by using a lot of people from other industries, we were able to, you know, really have a balanced sort of team. And also, lastly, generating jobs. Like I started this talk, we're all going to be made redundant. And on this project, we were able to kind of get jobs for people who you know wouldn't have worked in the games industry before, because we had these great tools to incorporate their work. And as much as we maybe think that games is, you know, on the down because we have had a lot of redundancies, I suppose, recently. In general, it is a growth industry, and that's not the case, you know, for theatre and some of these older kind of crafts. So, conclusion. Are we destined to be eaten by AI, fed to the machines like Keanu Reeves? I don't think so. I don't think we should worry about AI taking our jobs. Think about how AI can enable new ways of working, be the Picasso of video games. Right, well, thank you very much for listening. And if you have any questions, I'll be able to answer them.
Hello, and thank you for your talk. It was nice. I saw when you talked about model making, on top of just the characters, you also had objects like chairs and stuff like that. Were all of the objects in your game made using models in that way you just showed?
Yeah. So every thing in the game so far is all handmade, except for the eyeballs and the lips of some of the characters, because they are the only bits that kind of animate that we couldn't really do, with the models. But yeah, pretty much everything, all the chairs and furniture is handmade.
And was that purely a stylistic choice, or was it also easier for you guys to do it that route rather than the more traditional one of 3D model making and so on?
I think, it was probably, we wanted to explore this kind of way of working, I think. And I think stylistically it made a lot of sense, to keep everything in the same kind of, style. Yeah.
So in your experience, was it easier or than, the traditional way, or purely it was the best choice in order to get the stylistic, the style you wanted?
Yeah, I think if you had a team of good 3D, modelers using Maya or Blender or whatever, then I'm sure they could do it just as quickly, maybe quicker. I don't know. But yeah, that would be a different style. So I think it was part of the appeal of working this way, is it gives it a unique style, and hopefully that's something that's going to stand out, to consumers as well.
All right, thank you.
Well, thanks.
Hi, wonderful talk. Thank you very much. Knowing what you know now, what would you change or do differently, especially in terms perhaps of performance impact or platform broadness? Obviously, things you said about the nerfs and splats and things taking more of a performance hit. Did that push up like the minimum specs and maybe therefore the market you could address? Stuff like that.
Yeah. So, well, actually, I probably wasn't very clear. So in the game at the moment, we mainly use photogrammetry with polygon output. We do use Gaussian splats in a couple of places, but we found that to do the whole game with that the tech is not quite there, I think. So yeah, although even having said that, we are planning to do a Switch version, and I think we may have to drop the Gaussian splats for that. So.
Hi there. Thank you very much for the presentation. The Crackernuts game just looks genuinely interesting. When it comes to a game like that, do you see that as like a pipeline you could replicate and do another game in the same style where you would still, get theatre actors and craft makers? Is that in much in a similar way how like Mortal Kombat gave way with all the taking pictures of actors and such? Do you see that this is a pipeline you could replicate again?
Yeah, definitely. I think so. I think personally, we'd love to do another game in a similar art style. Maybe in a different genre, not sort of a narrative game, but maybe more of a RPG or something. And I think what's exciting me is that there's lots of teams out there. I think there have been some titles in the past that have used handmade models. Harold Halibut came out recently, which maybe some of you have seen, and there's been a few others. But it has been a very expensive way of working in the past. But the sort of, I think the doors are opening that a lot of people are going to be able to produce stuff in this style. And the nice thing is that there's not like a single style to model making, right? You can have them made of clay, of wood, of paper, of fabric. There's a whole diversity of styles within model making. So yeah, I think it has sort of a lot of potential there.
Thank you.
I think that's it. Well, thank you very much for coming, and enjoy the rest of your evening, everyone.